An Argand diagram is a block of complex numbers as points in the complex plane, using the x-axis as the real axis and the y-axis as the imaginary axis. In the previous lesson, we learned how to find the modulus and argument of a complex number in Cartesian form and express the complex number in polar form. We present a complex number a plus bi in Argand diagram. From the Argand diagram, we can find the modulus for the complex number a plus bi that is equal to length of the segment line that is equal to square root a square plus b square. And the theta is equal to argument of the complex number a plus bi equal to arctangent y over x. And the complex number also can be represented in the polar form. That is a plus bi equal to r bracket cos theta plus I sin theta. The polar form also we call it modulus argument form. Multiplication and division of complex numbers. We are given two complex numbers, z1 equal to r1 multiplied with cis with the theta 1, and complex numbers z2 equal to r2 multiplied with the cis with theta 2. Now we are going to do the multiplication of two complex numbers, z1 multiplied with z2. So equal to modulus r1 multiplied with modulus r2, then the cis theta 1 multiplied with cis theta 2. Then we are going to do the expansion for the part cis. So using the FOIL method, we do the expansion. Don't forget the I square equal to -1. So finally we have modulus R1 multiplied with modulus R2 multiplied with cis theta 1 plus theta 2. Multiplication of two complex numbers. Complex number z1 multiplied complex number z2 equal to r1 multiplied r2 bracket the cis theta 1 plus theta 2. Therefore, for the multiplication, we just do the multiply for the two modulus r1 multiplied r2. And for the argument z1, z2, we're going to do the addition for theta 1 plus theta 2, or argument z1 plus argument z2. Division of complex numbers. Two complex numbers z1, z2 are given. So divide z1 by z2 equal to r1 cis theta 1 divided by r2 cis theta 2. So we're going to do the rational, the denominator. So multiply the conjugate of the z2. So we have cos theta 2 minus I sin theta 2 to the numerator and denominator. Then we apply the FOIL method for do the expansion for the numerator and denominator. Finally, we have z1 divided by z2 equal to r1 over r2, then cis theta 1 minus theta 2. Conclusion of division of two complex numbers. z1 divided by z2, so we have modulus r1 over r2 multiplied with cis theta 1 minus theta 2. Therefore, the modulus after did the division, we have modulus R1 divided by modulus R2, and the argument Z1 over Z2 is equal to theta 1 minus theta 2, or argument Z1 minus argument Z2. Let's say we are given two complex number. Complex number 1, Z1 equal to 2 CIS pi over 4, and complex number Z2 equal to 5 multiplied with CIS pi over 2. Find A, Z1 multiplied with Z2, and B, Z1 multiplied with Z2 conjugate. Question A, we are requested to multiply two complex numbers, Z1 multiplied with Z2. So equal to 2 CIS pi over 4 multiplied with 5 CIS pi over 2. So we just do the multiplication for the modulus or moduli 2 multiplied with 5, and do the addition for the argument pi over 4 plus pi over 2. So we have 10 CIS 3 pi over 4. After find the cos 3 pi over 4 using the calculator, we have negative sec 2 over 2, and sine 3 pi over 4 equal to pi sec 2 over 2. So after do the simplify, we have negative 5 sec 2 plus 5 sec 2 I. Question B, we are requested to multiply two complex numbers, Z1 multiplied with Z2 conjugate. Before we go to the further solution, we have to find the Z2 conjugate. Z2 conjugate is equal to 5 cos pi over 2 minus I sine pi over 2. So we use principal argument to get the solution. So there is a quadrant 4. So we have 5 cos negative pi over 2 plus I sine negative pi over 2 for the conjugate Z2 conjugate. So we do the further solution. Modulus Z1 multiplied with modulus Z2. So 2 multiplied with 5. So CIF pi over 4 multiplied with CIS negative pi over 2. So we just do the addition for the argument. So 10 cos negative pi over 4 plus I sine negative pi over 4. So after using the calculator to get the cos negative pi over 4 and sine negative pi over 4, we have the 10 bracket sec 2 over 2 minus I sec 2 over 2. Then do the simplify, we get the answer 5 sec 2 minus I 5 sec 2. Question C, Z1 divided by Z2. So Z1 divided by Z2 equal to 2 CIS pi over 4 divided by 5 CIS pi over 2. So we just do the division for 2 over 5 and do the subtraction for the argument pi over 4 minus pi over 2. So we have 2 over 5 CIS negative pi over 4. Then using calculator to get the value of cos negative pi over 4 and sine negative pi over 4. So finally we have sec 2 over 5 minus I sec 2 over 5. Just for your memory, multiplication and division of two complex numbers in polar form. You just keep in your mind to find the product of two complex numbers, multiply their moduli and add their arguments. To find their quotient of two complex numbers, divide their moduli and subtract their arguments. Do it yourself the exercise. Question 1. Given complex numbers z1 equal to 8, CIS pi over 12, and complex number 2 z2 equal to 2 CIS pi over 6. Find their question A, B, C, D, E, F yourself.